Today's point is PN junction diode. Here PN junction diode is one electronic component which is used in most of the electronic devices for different applications. Here this PN junction diode has one important property, that it transfers current only in one direction and it blocks current in other direction. To construct this PN junction diode, two types of semiconductor materials are required. Here P means P type semiconductor and N means N type semiconductor. So first we will see the construction of this diode. When P type semiconductor is joined to N type semiconductor, then PN junction diode is formed. From P layer one terminal is taken called anode. From N layer second terminal is taken called cathode. Between these two semiconductor layers, one junction is formed called PN junction. Means the region, boundary region between P and N semiconductor, that region is called PN junction. So this is construction of this PN junction diode. It shows that on one side P type semiconductor is present and on another side N type semiconductor. So when P type semiconductor is joined to N type semiconductor, then PN junction diode is formed. Here it is called diode. Diode means two electrodes, means this device has two electrodes. Electrodes means terminals. Two electrodes are anode and cathode, and it has one junction, PN junction. Therefore name given to this device is PN junction diode. So this is construction, and the symbol of this PN junction diode is this is symbol of this PN junction diode. Again two terminals are shown, anode and cathode. Through this diode current flows from anode to cathode terminal. So the construction is very simple. Now next is the working of this PN junction diode. Working of PN junction diode. To explain working of this PN junction diode, consider three conditions: unbiased condition, second forward biased, and third reverse bias. Starting with unbiased condition. So when external voltage across terminals of PN junction diode is 0, called unbiased condition. Is here in this diagram, both terminals of this PN junction diode are open and external voltage is not shown and external voltage is not connected. So this is called unbiased condition. In unbiased condition, depletion region is formed across the junction. We know how that depletion region is formed. We know in p-type semiconductor, holes are majority charge carriers, and in n-type semiconductor, electrons are majority charge carriers. Holes carries positive charge and electron carries negative charge. As soon as p-type semiconductor is joined to n-type semiconductor, then across junction charge carrier moves, means here electron and holes cross junction and they move from high concentration region to the low concentration region. Here on n side electrons are large in number and on p side electrons are absent, and holes are large in number on p side and holes are absent in this n layer. So concentration of hole is more on p side and concentration of electron is more on n side. So charge carrier always moves from high concentration region to the low concentration region. Therefore, as soon as this p layer connected to the n layer, electron moves to the low concentration region, means towards p layer. Similarly, holes moves to the low concentration region, means towards the n layer, means holes moves towards n layer and electrons moves towards p layer. Means there is movement of charge carrier, and this process is called diffusion process. Means because of diffusion, charge carrier moves from high concentration region to the low concentration region, even if external voltage is 0. When electron cross junction and enters into this p layer, that electron recombine with the holes present in this p layer, means that electron recombine with the hole, and that acceptor atom present in this p layer, that acceptor atom accept the electron and atom is converted into ion. So after accepting electron, atom, that acceptor atom present in this p layer converted into the ion. So electrons present near to this junction enters into this p layer, they recombine with the hole, and after recombination the atoms are converted into the negative ions. Similarly, holes cross junction enters into the n layer, hole recombine with the electron. After recombination, the donor atoms are converted into ion. Is when hole is accepted by donor atom, then that atom is converted into positive ion. So here across this PN junction, on one side negative ions are formed and on another side positive ions are formed. This region is called depletion region. So this region is called depletion region. In this region only immobile ions are present. Means in this region free charge carriers are absent, electron and holes are not present. When there is recombination of electron and hole, then there is formation of these ions, negative ions on p side and positive ions on the n side. So this layer is called depletion region, because in this region free charge carriers are absent. Here negative charge is more on one side and positive charge is more on another side. So potential difference is formed across this junction. So on one side negative potential is more and on another side positive potential is more. So potential difference is formed across the junction. This potential difference is called barrier potential. Barrier potential, and the value of this barrier potential is 0.7 volt for silicon type of diode and 0.3 volt for germanium type of diode. So depletion region is formed, and depletion, because of that depletion region potential difference is formed, and potential difference value is 0.7 volt for silicon type of diode and 0.3 volt for germanium type of diode. This barrier potential opposes to the movement of charge carrier, therefore current is 0, no current flows to the PN junction diode in unbiased condition. Means here these negative ions repels these electrons, similarly positive ions repels these holes. So current is 0 if this depletion region is present in PN junction diode. So this is unbiased condition. Second is forward bias condition. So when positive of external voltage source is connected to anode and negative of external voltage source is connected to cathode of PN junction diode, then this type of biasing is called forward biasing. Here voltage source is used whose positive is connected to anode and negative is connected to the cathode. So we can call this voltage as Vf, that forward voltage. So when this PN junction diode is forward biased, anode terminal is positive and cathode is negative. So this positive anode terminal repels these holes. Similarly, cathode terminal repels the electron. If this forward voltage is 0, then current is 0, no current flows through the PN junction diode. If we increase this forward voltage in steps, for example 0.1 volt, then this cathode terminal repels few electrons towards junction. Similarly, this positive anode terminal repels few holes towards the junction. So from both sides charge carriers moves towards the junction, and this forward voltage decreases the width of depletion region. Means from both sides charge carrier moves towards the junction, and therefore depletion width decreases, because the reverse voltage is applied across the barrier potential. Here barrier potential has negative on P side and positive on N side. So opposite voltage is applied across the barrier potential. Therefore that barrier potential decreases if we increase this forward voltage. So with increase in this forward voltage, this width of depletion region decreases, therefore barrier potential decreases, and therefore resistance of PN junction diode decreases. when this forward voltage is equal to 0.7 volt for silicon type of diode, when forward voltage is equal to 0.7 volt for silicon type of diode, this depletion region is completely removed. This depletion width is minimum, and if we increase this voltage beyond this value 0.7 volt, then electron cross junction enters into the P layer. These electrons are attracted by positive anode. Similarly, holes cross junction and enters into the N layer. Positive holes are attracted by the negative cathode terminal. So electrons moves towards positive of external voltage source. Similarly, holes moves towards negative of the external voltage source. So with increase in this forward voltage, more and more holes and electrons cross junction, and there is movement of charge carrier. So current flows through the PN junction diode, and direction of current is opposite to direction of electron. Here electron moves towards this positive, therefore direction of current is opposite to direction of the electron. And in forward bias condition, we can call that current as forward current, that is IF. So current flows through the PN junction diode when that PN junction diode is forward biased, and direction of current is from anode to cathode terminal, So this is working of PN junction diode in forward bias condition. Next is reverse bias condition. So when we change the terminals of external voltage source, means if anode is negative and cathode is positive, this type of voltage is called reverse voltage. So when PN junction diode is reverse biased, then current through diode is 0. So reverse biasing means when anode connected to negative and cathode connected to positive of external voltage source, this type of biasing is called reverse biasing. Because of reverse voltage, charge carriers moves away from the junction. Here if this reverse voltage is 0, assume that reverse voltage is 0. When that reverse voltage is 0, that depletion region is present. Here depletion region is present. Consider that this is the original width of this depletion region when reverse voltage is 0. When we increase this reverse voltage in steps, for example 0.1 volt, here cathode terminal is positive, anode terminal is negative. Therefore, this cathode terminal attracts electrons. Here electrons are attracted by this positive cathode terminal because there is attraction between unlike charge. Electron carries negative charge and cathode is positive, so there is attraction. So electron moves towards cathode and holes moves towards anode because hole carries positive charge and anode is negative, so there is attraction between unlike charge, that is holes moves towards anode terminal. So with increase in this reverse voltage, for example 0.2 volt, 0.3 volt, more and more electron and holes moves away from the junction. Therefore, this depletion width increases. Depletion width increases with increase in the reverse voltage. So when depletion width increases, that barrier potential increases, so resistance of PN junction diode increases. So in reverse bias condition, this PN junction diode offers very high resistance because of presence of this depletion region, and current is 0 when diode is reverse biased. So reverse current IR is equal to 0 when PN junction diode is reverse biased. So in this way, in forward bias condition, current flows through the diode, and in reverse bias condition, current is 0 through the diode. So diode is on when it is forward biased, and diode is off when it is reverse biased. So this is all about the working of this PN junction diode.